We've been talking about factoring and what it means to factor, and the next topic that we're going to talk about is factoring trinomials. Trinomials means things with three terms, polynomials with three terms. So far what we've looked at is factoring using GCF and factoring things with four terms, and today we're going to look at factoring three terms. You could factor any polynomial with GCF. You could try to factor any polynomial using GCF. The grouping method is specific to four terms, and today the method that we're going to learn is about three terms. We've been talking about factoring in the way that when you multiply two items together, you end up with some product. When you take that product and try and undo it, that is what factoring is. And when we factor a trinomial, we're hoping to break it into two binomials. We're trying to take something with three terms and break it into two separate items that have two terms apiece. The method that we're going to use, I like to call star method. And the reason I call it that is because what you do, anytime you have three terms, we'll call them ax squared plus bx plus c, call it a quadratic trinomial. And the way that you do this, you draw a star. It's an x with a horizontal line through it. And the items that you're going to put in that star are always a, that's your coefficient of the x squared term, a times c, that's your leading term times your trailing term there, the leading times the constant, and in the bottom, b, that's your x coefficient. This is the same a, b, and c that you would use in quadratic formula. And then what we're going to do is we're going to try and fill in these items down here. We don't know what they are, but we're going to try and fill them in. And the way that we're going to fill them in is we're looking for numbers that multiply to the top and add to the bottom. All right, I think the best way to see this is through some examples. So we're going to jump straight to an example here. If we were trying to factor this trinomial, x squared plus 4x plus 45, notice it has 1, 2, 3 terms, and it does not have a GCF. So always we're first checking to see if there's a GCF. If there's not a GCF, we count how many terms. Since there are 3 terms, we're going to go to the star method. And in the star method, remember the top is a times c. So 1 times negative 45 is negative 45. A is 1, and b is 4. And now what I need are numbers that multiply to negative 45 that also add to 4. And what you could do is come over to the side and make a little chart, multiply and add. We want to multiply to 45 and add to 4. Multiply to negative 45 and add to 4. What are some numbers that multiply to negative 45? Let's see. Multiplying to negative 45 would be something like 3 times negative 15, or negative 3 times 15, or 5 times negative 9, or negative 9 times 5. Let's see what these add to. If I add 3 plus negative 15, that gives me negative 12. Negative 3 plus 15 is positive 12. 5 plus negative 9 is negative 4. Negative 9 plus 5. Oh, I'm sorry, I should have flipped the signs there. I have a negative 9 and a positive 5. Negative 5 and positive 9 adds to positive 4. Remember, we're trying to add to 4, and so that last combination that I just found is the correct combination. Negative 5 times 9 is equal to negative 45, and negative 5 plus 9 is also equal to 4. So they multiply to the top number and they add to the bottom number. All right, the key from this point is your variable is going to go with the top. And typically what's going to happen is it's going to be your middle variable. But for this to work, really, I should have qualified this and said that this exponent has to be double what that exponent is. So since this is an x to the 1 and that's an x squared, it is double. And we're going to take the middle one. So that's an x to the 1, an x to the 1. If you can simplify these fractions, you should. Now, if the top is 1, if a is 1, we'll never have to simplify those fractions. So if a equals 1, we don't have to worry about simplifying the fractions. If a is something other than 1, we need to simplify the fractions. All right, so here, since a is 1, we don't have to simplify our fractions. What we're going to do now is just write these left and right wings, the things that I circled as the fractions. We're going to write those left and right wings as our factors. So this is going to end up being 1x minus 5 and 1x plus 9. 1x is the same thing as x. So x minus 5 and x plus 9. Those are our two factors. And I'm not going to check this. I'll check the next one. those should, if I multiply them back, should get me back what I started with. Remember, factoring is breaking something into its multipliable pieces. Let's try the next one. I'll pick a different color here. So remember, the top left and top right are A and A. That's 1 and 1. This is in order A, B, C. And we're just taking the numeric part. We're taking the coefficients. So A is 1 and 1. A times C on top is negative 14. B on the bottom is negative 5. A very common mistake is just starting to put C there. Remember, that is A times C. It's not just C, it's A times C. It just so happens that we have 1 times 14. All right, we need numbers that multiply to negative 14 and add to negative 5. I'm not going to do this chart every single time. I'm just doing this for the first few so we can get used to it. We need numbers that multiply to negative 14. So that would be something like 2 times negative 7, negative 2 times 7, 1 times negative 14, and negative 1 times 14. Can we get them to add to negative 5? As soon as we find a combination that adds to negative 5, we're done. And these, actually, I got lucky in the very first combination that I made, adds to negative 5. So that is my combination. These add to positive 5, these add to negative 13, these add to positive 13. There's only going to ever be one combination that works, 2 and negative 7. Now, I say the one combination. It doesn't matter what order that combination is in. So even though I wrote 2 and negative 7, if I wrote it in the other order, negative 7 and 2, that's still correct. It doesn't matter the order that they go because they still multiply to the top and they still add to the bottom. All right, take my variable and place it on the top and try and simplify that fraction. Because A is 1, I cannot simplify that fraction. That gives me x minus 7. And this one over here, can't simplify that, gives me x plus 2. That's 1x plus 2 and 1x minus 7. The same reason as I said earlier, it doesn't matter what order those came in. I could have written them as x plus 2 parentheses x minus 7, right? The order of those doesn't matter. If I was to distribute these back, so that's my answer. If I wanted to check my answer, I could distribute or FOIL these back. That would give me x squared plus 2x minus 7x minus 14. You can check me here. That gives me x squared minus 5x minus 14. And notice that that gives me what I started with. So that's the way that you check these answers, is you can distribute them back and make sure you get what you started with. Let's try another couple. I'll do one more with you, and then I'm going to let you try one. So here, this top one, w squared minus 15w plus 50. Remember, a and a on top, b on bottom, and a times c, that's 1 times 50 is 50 on top. We need numbers that multiply to 50 and add to negative 15. We can just start to think in our heads. We're going to do a double check over here. Numbers that multiply to 50 and add to negative 15 would be things like 5 and 10. Negative 5 and negative 10. Let's see, 5, 10, 2, and 2 and 25. Negative 2 and negative 25. Because I'm trying to multiply to a positive 50, I can either have 2 positives or 2 negatives. Either of those will multiply to a positive. Now, the reason I'm listing both is because these are going to add to 15, but I don't need 15. I need negative 15. I miswrote this second. It's negative 5 and negative 10. Multiply to 50. Those add to negative 15. Those add to 27. These add to negative 27. And notice I want them to multiply to 50 and add to negative 15. And so that's my winning combination there. Negative 5 and negative 10. Again, if you had written it as negative 10 and negative 5, that's perfectly fine. The variable at hand here is a w. So my factors are w minus 5, w minus 10. Pause the video and see what you can do here. Here's what my star looked like. The numbers that I found that multiplied and added to the correct numbers are negative 4 and negative 12. And so then my two factors should be z minus 4 and z minus 12. Because the variable that we're using here is z. Remember, we're taking that middle item there. All right. If it is not in descending order, then we need to write it in descending order first. All the examples that we've had so far, we haven't said it out loud, but they've all been in descending order. That means from highest exponent to lowest exponent. This one is not in descending order, so the first step here is to rewrite it, just reorder it in descending order. Once you do that, you can do your star method again. You can pause the video and try this one yourself. This is what that should look like. The numbers that multiply to negative 48 and add to negative 8 are negative 12 and positive 4. And so the two factors we should have are p minus 12 and p plus 4. remember taking the middle exponent there. I'm sorry, the middle variable there. Try this one. I'm going to show you what my answers were in about 3 seconds. So first, we need to write it in descending order. Then we need to put it into our star method, find the numbers that multiply and add, and then we write out our two factors. Factor the trinomial. It doesn't matter what method it says, trial and error method, AC method, guess and check method. It doesn't matter what method it says. If we look at this polynomial, the first thing we always want to do is try and take out a GCF. Once we've tried that, we look at how many terms there are, 1, 2, 3. And since there are 3 terms, we're going straight to star method. Now, notice here that A is not just a 1, A is a 10. And so we know that we're going to have to simplify these fractions at the end. If A is not 1, we will have to simplify the fractions. The top, remember, is A times C. 10 times 1 is 10. And the bottom is B. Now I need numbers that multiply to 10 and add to 11. So multiply to 10 and add to 11. We'll have 2 times 5 is 10. Negative 2 times negative 5 is 10. 1 times 10 is 10. Negative 1 times negative 10 is 10. And we need them to add to 11. These add to 7, negative 7, 11, negative 11. I think we found our winning combination there. Those add to 11. So positive 1 and positive 10. Remember, we're going to place our variable on top, x, x. And then can you simplify 10 over 1? You can't divide them by the same number, so we're saying we cannot simplify that. That's 10x plus 1. Can you simplify 10 over 10? You can. That's the same as 1 over 1. Now, you do have to keep something in both the top and bottom slot. And so a tendency here would be for people to call this just 10x. That's not correct. Remember, we have to get 2 binomials. We do want to leave it with something on top and something on bottom. The same thing on the right. We don't want to leave it as 1 over 1. We don't want to leave it as just 1x. We need something on top and something on bottom. If it's just a regular number, we just put it over 1. So if that's simplified to 5, we call it 5x over 1, or 5x plus 1. This is an example of where A was not 1. We absolutely have to check those wings and see if we can simplify the fractions. Here's another of those. It says factor by the AC method, but the way that we're going to do this is we're going to look and say, is there a GCF? There's not. There's 1, 2, 3 terms, and so with 3 terms, we're always going to go to star method. The top left and top right are A, and since those are not 1, we know we're going to have to simplify our fractions on the left and right. The bottom is B. Top is A times C is 12. All right, we need numbers that multiply to 12 and add to 7. Multiply to 12 and add to 7. I think I can find an easy combination. 3 times 4 is 12, and 3 plus 4 is 7. The more of these you do, the better you will get at finding those two numbers. All right, middle variable goes with the top. That's x and x. Can you simplify 2 over 3? You cannot simplify that one, so our factor there is 2x plus 3. Can you simplify 2 over 4? Yes, you can. That's 1 over 2. We're simplifying it just like a fraction. We're just trying to divide the top and bottom by the same item. If you could divide the top and bottom by the same item, you should do that. And those are your two factors. We don't have many more of these. I've got this one set up for you. We've got A on the top left and top right, B on the bottom, A times C on the top. Can we find numbers that multiply and add? Multiply to 6 and add to 5. Should be an easy combination. 2 times 3 is 6, and 2 plus 3 is 5. 2 over 2 is the same as 1 over 1, and so that is the same thing as x plus 1. 2 over 3 does not simplify, so that's 2x plus 3. All right, take a second, pause the video, and try this one on your own. This is what my star method looked like. Notice the left side will not simplify, but the right side will. And so those are what my two factors like when the right side simplifies to 1 over 2. Same thing here. It was not in descending order, so I went ahead and rewrote it in descending order. Pause the video and try this one. This is what my star looks like. The left side will simplify to 1 over 2, and we're using y as our variable, so that's y plus 2. And the left side won't simplify, so our factor there is 8y minus 3. Those are the two factors. We have factored that trinomial. This is the last one that we're going to do here, a difficult one, factor. And remember I said the first thing you want to do always is try and take out a GCF, and this one actually does have a GCF, so that's where we're going to start. I can take a 10 out of every item and an x out of every item, and I'll have left 4x squared minus, oh, I can't take a 10 out of every item. What am I doing? I can't take a 10 out of 104. I can take a 2 out of every item, so I'll take a 2 and an x. If I take a 2 and an x, I'll have 20x squared minus 52x plus 5. And then from there, I'll leave this as an assignment for you. I would try and do this by star method. When we come back, we're going to talk about two more methods of factoring, and those are for binomials. So we've talked about factoring things with 4 terms, factoring things with 3 terms. We need to talk about factoring things with 2 terms.